What is up, YouTube? Woo! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. Next, here are some announcements for the day. Please pause the video and read them. Today, you will be able to explain how a lava lamp works using density. First, I'm going to do a little review on what we learned last week. Density is how much mass there is per volume or in volume. So if something's more dense, it's packed together, whereas something that's less dense will be spread out. Here's like an example of what the atoms would look like and something that's more dense versus less dense. Remember, so if you have hot water and cold water, okay? If you look closely at the water molecules, you should notice the hot water, the molecules are more spread out. So you should be thinking more spread out, hot water is going to be less dense. More dense is heavier in less space, less dense will be lighter in more space. Both the hot and cold water look like they have the same size, but it looks like the cold water is a little bit heavier. If cold water is more dense, which one will sink? Try and think about it now. This is a little review. Remember, if something is more dense, it'll sink. So cold water will sink below hot water. And if you use food dye, you could see here. So if you dyed hot water red and cold water blue, the blue water would be below the hot water because when atoms get hot, they spread out. So when the atoms get hot and spread out, they get less dense and then they go float up, which is why heat rises. That's some review. And remember, we're going to bring it back to the Earth. So the Earth has like a mini sun in the center, the Earth's core. So where do you think the hottest lava will be? Do you think the hottest lava will be on the crust, on the surface, in the air, in the ocean, or near the center of the Earth? Lava is actually hottest near the core. What direction will lava go when it gets hot? Will go up, down, left, or right? What do you think? You should remember, hot lava will go above cold lava. Cold lava, just like water, liquids that are hotter will go up. Okay? So where do you think the lava will go when it gets cold? So the lava will go up when it gets hot. What will happen to the lava when it gets cold? Lava gets hot. This happens actually with heat. So the lava will get hot, and then when it gets cold, because it's no longer near the mini sun, it'll fall down when it's cold. And that's because hot liquids are less dense than cold liquids, so the hot things go up, and then when they get cold, they fall down. Heat travels in a circle. Here's an example of like convection currents. That's what they're called. A sneak peek for Wednesday. So if you have a heater in your home, the heater makes the air hotter, and then the hotter air goes to the ceiling. But it'll be colder near your window, so the air will get cold once it's near the window, and then it'll fall back down. And then when the air gets close to the heater, it'll go back up again because hot air rises. And then when the air gets colder, it'll fall back down. And it'll constantly get cycled. Gets hot, it goes up. When it gets cold, because it's no longer near the heater, it'll fall back down. It also works for cooking. So like if you have food near your stove, if you look up like stove convection currents, you can see like in the stove heats up the food at the bottom, and then when the air gets cold because it's no longer near the stove burner, it'll go back down to get hot again, and then it'll go up, and then when it gets cold, it'll go back down, and it'll get hot and go up, and then when it's no longer near the heater, it'll go back down. That's how it works in the Earth too, and in your home, and when you cook. Next, we're gonna do a race. And I don't mean like physical race, like you're sprinting. I don't mean skin color race. I mean race as in scientific writing. I know you've learned this in English class. The R means restate. So reword the question, turn it into a statement using your own words. The A is for answer it. C, cite evidence. And E is explain. I'm going to go over each one in an example. So let's say I had the question, why does air pollution raise the temperature on Earth? That's a question I have to answer using race. The first part is restate the question. So I'm not going to say anything new. I'm just going to change this question, take away the question mark, and make it a little simpler. So if the question is, why does air pollution raise the temperature on Earth? I'm just going to say, air pollution makes it hotter on Earth. Just agree with the question, take out the question mark, and put a period. Next, the A is for answer. So now I'm going to say what actually makes it hotter on Earth. And that would be carbon dioxide. Carbon dioxide in the air makes it hotter on Earth. And now I'm going to give you evidence. So let's say if I gave you data, the evidence would be if I give you data on like CO2 in the atmosphere versus Earth's average temperature versus the year. If I give you data, you talk about like what happens when something's low and then what happens when something is high. So here's my example. When there was 50 million tons of CO2 in the atmosphere, the average temperature on Earth was 49 degrees. Last year, 2020, when there was 1.3 billion tons of CO2 in the air, the temperature was 11 degrees hotter, or 60 degrees. So that would be evidence. I'm showing you data using numbers why carbon dioxide in the air makes it hotter on Earth. So there are two ways you can give evidence. You can use data, like I just did with numbers, or we can use quotes. So a quote is like you're citing something from a reading. Like scientists say the changing climate is caused by the increase in CO2 from air pollution. That'd be an example of another cite evidence, but using a quote. You'll usually have to use both in my class. Next, E is explain. This is the hardest part. A lot of people forget to explain. When you explain, all you do is just answer the question again. So like air pollution causes temperature to increase, and then say because, and they give me the reason why it's actually happening. So you answer the question again, but then you give me a reason why it happens. So air pollution causes the temperature to increase because, that's what I look for when I want an explanation, because the carbon dioxide in the air traps heat and makes it hotter on Earth. This is called the greenhouse effect. Explaining is the hardest part, so I'm going to give a little bit more examples. So when you explain, it means to give reasons for why your answer is right. When I grade, I look for the word because, so I know that you're giving a reason to explain yourself. For example, if someone asked me, like, who do you think is going to win the playoffs this year? I would say the Lakers are going to win the playoffs. That would be my answer. And then my reason would be because they have two of the best three players in the NBA, Anthony Davis and LeBron James. That's an example of an explanation. Or if someone asked me, why do eggs float in salt water? I would answer the question, the egg was able to float in salt water because, here's my reason, because the salt water is more dense than the egg. Another way to put it too, the egg floats because things that are less dense float, and the salt water was more dense than the egg. If someone asked me, what's the best anime of all time? I would answer, Promised Neverland is the best anime of all time. That's my answer, and then my reason is because it is the highest ratings possible on Rotten Tomatoes. Okay, the reason why you're doing all that, here, pause the video now if you want to check. This is the entire race all coming together to talk about air pollution. Now you're going to explain to me how lava lamps work using race. So if you go to Monday, lava lamp race, you have a reading about how lava lamps work. So you read that, use the reading to fill out the table to get the data, and then at the very end, you explain to me using race how do lava lamps use density to move the bubbles up and down. That is the last thing. You'll fill out the box, and at the very end, look at my rubric, try and read the rubric and figure out where would you be. Are you 15 out of 15, 14 out of 15, 12 out of 15, 10 out of 15, or 0? Grade yourself. Okay, that's the last night, everyone. When you're done, please take the 10 survey, and then you're all good to go. Thank you, everyone, for watching the whole video. Bye.